In today's video, we are going to cover how to design and build a complex solar power system with raw lithium iron phosphate prismatic cells. And if you can build a battery with these cells, it will last a very long time, it will be extremely safe, and it will be very, very cheap. And these are very common, you can buy them off of Amazon. And so what a lot of people don't understand is how to use these in a full system and how all the parts need to work together. So in this video, we're going to talk about how these system components talk to each other. We're going to learn how to program different components so that you have safety features that you otherwise wouldn't have. If you have built any other batteries in the past or small solar power systems, you should be able to build this. This is all low voltage. This is just automotive primary wire. Everything here you can buy off of Amazon or an auto parts store locally. A lot of people, when they build these systems, they are limited by the BMS. And most of the time the BMS is limited discharge-wise from 60 to 100 amps. And so for this system, we used a converter and a 12-volt relay that you can buy at any automotive store. And that enables us to use a 220 amp battery protect. So instead of using 60 to 100 amps as your limit, you are using 220 amps at 24 volts. That is a huge difference. That means that now you can actually build a bank with all of your cells in series and you do not have to parallel them. You don't have to buy a bunch of Battleborns and put them in parallel. Instead, you can buy the raw cells and you can buy them up to 400 amp hours in size. These are very small cells because this video is for demonstration purposes only. When you have enough safety features in place, you can't really hurt these batteries. They will take care of themselves, and these can last 3,000 to 5,000 charge cycles. So a very, very long time. And it's great to see this video and watch me do it in real time, but please check out my website because it will show everything you need in a nice little schematic, and it might be easier for you to wrap your mind around it instead of seeing all of these wires. And there is so much more to talk about, so let's just build it and you guys can learn with me. So let's get started. So the first step is building this lithium iron phosphate 24-volt battery. Please check out my other video where I explain how to do this and how to bottom balance these cells. It's very easy to do. We have some bus bars included with these battery kits, and all of the cells come matched by internal resistance and capacity, so you don't really have to think about anything. You just assemble it together how you want. For me, I like using VHB tape, and it holds the cells together nicely. You can also use hose clamps. And this pack is completely done and balanced, so what we need to do now is add a BMS. And this is one that I really like by Dali, and it's a lithium iron phosphate 8-cell 24-volt BMS, and it can handle 60 amps of discharge current. So that means I can use this BMS safely with a 1,000 watt inverter, and we'll have some extra safety headroom for surges and induction loads. And the first step in installing this is removing the balance cable. And now we need to connect this balance cable to the individual cells of our 24-volt battery. And these wires are really small, and these terminal studs are really small, so we can get by with using this one. And usually the wire ends come soldered, so what you want to do is trim all these wires off so it looks like this. And then strip the ends, and they will end up looking like this. And then slide the connector over the wire, and then squeeze real tight. And then repeat the process for the rest of the wires. And this is what they'll look like when they're all done. Now we need to add this balance cable to the battery, and this is where people screw it up sometimes, so we need to do this carefully. So on this battery, we have the main negative on this side and the main positive on this side. We will start at the negative terminal. And on the balance cable, you will have a black wire. So we're going to put this wire on the main negative terminal. Next, you're going to look at the balance plug and take the next wire, and this will be your first cell positive. And to know which cell is the first cell, it will be wherever the negative wire is connected. This is the first, then second, then third, and fourth. So we want to connect it to the first cell positive. Super simple. Now for the next one, we want to do second cell positive. So we're going to take the next wire on our balance lead, and now we have the second cell positive installed. Super simple. And now we have all of the cells connected to this balance lead. So the next step is connecting the BMS to the battery, and then we can plug all of these cells in. And when you look at your BMS, you will see a B-. So this blue wire, we need to cut it and strip it. And this is a 10 gauge wire, so we can use a standard yellow size. Just make sure that it fits the stud. And typically I like to add these to the sides of the battery because they don't get that warm. But if you have a long-term installation, you want to attach this somewhere near the battery, but not on the battery. And with all this excess wire, you can tie a knot, and it usually looks pretty good like that. And now that the negative is connected to B negative, we can finally plug in the balance cable. Now the next step is checking if our BMS is actually on and working. And so this is the main negative. So what we want to do is take a multimeter negative on the output and then on the positive main, and we have 26.53 volts. If this was a really low number for the state of charge of this battery, that means that one of these wires is not connected to our battery well enough, or this plug is not plugged in all the way. But if the voltage is around 26 volts, and then when you check the voltage down here, it's the same, that means that the BMS is on and working properly. Now what we're going to do is add an MPPT by Victron Energy. This has a low temperature disconnect and it will work perfect with our system. And on the charge controller, you have a positive and a negative. So you want to connect it to the main positive, and then the output negative will go into the negative battery terminal. And so I drilled a small hole so I can put a bolt through here, and then I can use it as a stud to connect all of my negatives. And now all we have to do is wire up this charge controller. So negative goes to negative, positive goes to positive. And this is a 20 amp solar charge controller, so 10 gauge wire at this distance works well. If you have a larger controller, you need a larger wire. But luckily we're doing 24 volts, so the amount of amps going through this is very minimal. And for most systems, I recommend a fused line going to the solar charge controller. But because this BMS has overcurrent protection and these wires are so short, it would be able to trip the 60 amp protection with this wire. So what we're going to do instead is have a bare wire going from the positive to the positive battery on the solar charge controller without a fuse. But you can add a fuse if you want. And for a 20 amp controller, we would do a 25 amp fuse. And we got a little bit of a spark, and the solar charge controller is now on. And now what we need to do is make sure that this thing is actually working. So we're going to log into the app, and now we can program a custom charge profile for this battery that we're working with. So go up to settings and then press battery. And now we have 24 volt, and this is a 24 volt battery, max charge current, that's good, charger enabled. And then go down to lithium iron phosphate. You can find it in the select preset menu, and then select lithium iron phosphate and press OK. And these voltages will work perfectly with this BMS. So you don't have to do anything. Also, the low temperature cutoff and temperature compensation, the settings are perfect for this battery. So this takes seconds to set up, and then press back, and you're done. But in order for the low temperature disconnect to work, we need to add a smart battery sense by Victron. This is a temperature sensor and also a voltage monitor that will tell the solar charge controller information about the battery. And so we're going to have to install this next in order for the low temperature disconnect to work on this charge controller. And this is really easy to set up. You just have a positive and a negative. But before we disconnect any of these wires, we need to unplug this BMS. Now that it's disconnected, it's safe to remove these terminals. Small blue light will start to flash. It also has a double-sided adhesive on the back, and you want to mount that somewhere on your battery. And that's it. Now we just need to connect this to this charge controller. And now that everything's connected together, we can put the BMS plug back in. And then open up your Victron Connect app. This was actually hard for me to connect. I had to use the password 000000 to make it connect to my phone. If you don't do that, it's a big pain in the butt. And so to connect this module to our charge controller, we need to press Settings, VE Smart Networking, and then you want to create a network. It takes seconds. I just made up some random name, and then it will ask, do you want to connect to the solar charge controller that's on your list of appliances that are connected? And then once you have that connected, back out. So head on over to the charge controller settings, and then press Settings, and then VE Smart Networking. And look at that, it's connected. So right now, if the battery temperature goes too low, and we go over to our battery settings, and the low temperature cutoff is at 5 degrees Celsius, once it hits 5 degrees Celsius, this charge controller will stop charging. So that's really important. Once that's all set up, you are good to go and you can exit out of here. Now what we can do is actually connect some solar panels to this system. Outside I have two 100-watt solar panels and I have some wires coming inside. We have a positive and a negative, and we're going to connect this to the negative and the positive for PV, and that means photovoltaic or the solar panel. So you have two inputs and you just need to stick them in there. Now our solar panels are connected and the blue light turned on, so it's in bulk charging mode. And if we pull up the app, 32 watts are going into our new built battery system. Now that we have the charging system built, we need to add an inverter so that we can actually use this power. And so this is a 2000 watt pure sine wave 24 volt inverter, but I definitely recommend for this size BMS using a 1000 watt. And so we have two copper wires, and one will go to the main negative on the output of the BMS, and then the other one will go straight to the positive. But because this has capacitors inside and we do not want to trip this BMS, it's smart to put the negative and the positive on the main terminals, get a little spark, and then connect it to the output. But whenever you mess with this terminal that's connected to also the solar charge controller, you want to disconnect the solar panels so you do not damage this. If this is connected to solar panels only, it can hurt it. Now that it's disconnected, we can add our inverter wire. And right now I've run into a problem. The BMS has tripped into overcurrent because it had to charge up the capacitors in this. There's always a spark for this one. So I charged up the capacitors in the inverter, but not this. So how are we going to turn this back on again? Because if I just plug this plug in, it will not turn back on. So what we need to do is short out both of these and then plug it in. Just like that. You see that? That was a big old gnarly spark. And then we can plug in the BMS. And guess what? Everything's turned on again. So now we're going to check the voltage of everything and make sure it's working. And we're at 26 volts, so that worked perfectly. Now that the charge controller is on and the inverter is connected, now we can connect the solar panels to our system. And so right now it's charging in bulk mode. We have a BMS, we have low temperature disconnect, and we have AC power. So this is a complete system. You could have just this alone and it would work fine. That's really cool, actually. I love this, man. These are so fun to build. I mean, come on, isn't this cool? That was so easy. So now let's actually test this. Let's put a load on this inverter. So I added a heat gun and we're gonna turn on this inverter. But keep in mind, we can only use 60 amps out of this thing. And to stay on the safe side, you're better off doing 50 amps.
50 times 24 is 1,200.
So we can pull 1,200 watts from this heat gun safely. So to be on the safe side, let's add a watt meter. All right, so right now we're pulling 1,100 watts from our battery. Actually, let's do a capacity test. Let's see if the BMS will turn it off when it gets too low. So the inverter just shut down. We have a new problem, and I found out it was an over temperature disconnect for the BMS itself. If you use a large load such as inverter through this for a prolonged duration, which I did it for about 15 minutes, this will disconnect. So what we are going to do is learn from this and find a way around it. What we're going to do is use a battery protect to connect our large load such as this inverter directly to our battery. So we will bypass this BMS, but in order to do this safely, you need to have all of these cells bottom balanced, and we need to change the settings on this battery protect. So we'll disconnect it like 12 or 12.6 volts, and that's around 10 to 20% state of charge for this cell chemistry. But what this will enable us to do is instead of 60 amps, we can pull 220 amps. So this will be really cool, but understand that if you do not have a solid bottom balance, this doesn't see the individual cell voltages. This BMS does see the individual cell voltages. So if one of these dips too low, this will disconnect all of the loads. But on here, you need to trust that your cells are bottom balanced perfectly and that you have the settings proper for our application. You want this at a high enough voltage so that even if these cells do go out of balance over time, it will still be able to disconnect the loads. This is actually a good problem, and I'm glad that it happened on this video, because if we had the charging and discharging on this one single BMS, and let's say we built a system around that, what if it disconnected the loads? It would also disconnect our solar charge controller. And if our charge controller was still connected to solar panels, this could be destroyed. So having a low voltage disconnect for our large loads and having the BMS take care of balancing and charge protection is a really nice hybrid system. You just need to make sure that your cells are bottom balanced. This will take care of most of the balancing, but after a certain threshold. You want to do your initial bottom balance when you're building the battery, which I cover a lot in my other video on how to build this battery. So yeah, now we're going to connect a battery protect between the battery and the inverter, and we're going to set the settings so that it actually works. Also, what's cool about this is like a fuse. It has a circuit breaker or over current protection, so it will actually disconnect the load if this wire is ever damaged. So yeah, let's hook this up real quick. And so to bypass this BMS, we're going to take the negative wire that was connected to the BMS and connect it directly to the battery instead. So now we have the battery protect connected, and I noticed that with the ground cable, we can actually connect it right here. So that means that if the BMS notices that one of the cells is too low, it will disconnect the battery protect as well, because it needs that, unless it will shut down. So that's perfect. But the more logical way to approach this is to use the remote terminals. So when these two terminals are shorted out with this little wire, the battery protect is on and it connects these two terminals. If this gets pulled out like this and these are open circuit, then these will disconnect. So what you could do with these terminals is run two wires to a relay and connect it to your BMS. So the cells are monitored and then it will disconnect this remotely. I am going to program this voltage to be higher than the disconnect for this, so I can get by with using just the ground wire as a fail-safe. But long-term systems, if you want something that uses the full capacity of the battery and you're not doing any charge or discharge cycle bandwidth modifications, you can just use the ground. That will totally work fine. So check this out. We have the inverter negative on the main negative of the battery. We have the ground going to the BMS output. And now we're going to connect the inverter positive. And so there should be a little bit of a spark. Oh, it was very tiny. I already charged the capacitors earlier. And now we can connect it to the out on the battery protect. And if you've never programmed this before, it's very easy. You just need to have a wire and short out the program terminal. So let's do that real quick. So first unscrew the program terminal and insert a tiny wire. A lot of people get scared by this, but it's very simple. So remove the remote plug, this little tiny one right here, and then take the remote wire that we added and press it on the negative. And you will see it flashing the numbers, and we need to go to option 8 and let go. And now let it sit and it will flash and it's done. We are totally good to go. And if you want to verify that you have the proper settings, we need to just touch it for a second and then let go. And it will say A and then 8. It's on option 8. And the reason we want option 8 is if you look at the table on the manual, it says under voltage shutdown for a 24 volt system, it will shut down at 24 volts. Or the equivalent for a 12 volt system will be 12 volts exactly. And for lithium iron phosphate, it's around like 5 or 10% state of charge when it hits that voltage. So that means that this will disconnect before this does. And you need to set it to option 8 if you have a lithium iron phosphate battery. There are some other options, but I do not like cycling these batteries below 10% state of charge. It's not worth it considering how much longer these batteries last for. Also, it said option A, and that means that it's buzzer or LED mode. If you want to use a relay or lithium ion with a larger system, you need to use the other ones. But for 99% of people, just have option A and then setting 8. After you have verified that your settings are saved, put the remote plug back into the battery protect, and now you will have power. And so now we can use large inverters. Isn't that great? So I can't really do a capacity test because these are like partially discharged anyways, but I just connected the solar panels and it's in bulk charging mode. So we're going to charge these up until they're completely full, which will be managed by the BMS. And then I can discharge it with this, which is managed by this. So this is really cool. Everything here works together. So I'm waiting for this to charge and I thought, why not actually connect a proper low voltage disconnect relay system? So these are very easy to use. When this has power, it will close these two terminals. And then when this disconnects because any of these cells go too low in voltage, then it will switch the relay and it will make these open circuit and it will disconnect our loads. And these are so simple, very easy. But the hard part is we have a 24-volt battery, and we have a common 12-volt relay that you can buy at the automotive parts store. So how are we going to make this work? We are going to add a converter board from the output negative of the BMS to the positive on the battery, and then that converter will give us 12 volts. And a lot of people watching this video probably still want to power their 12-volt appliances, so this will work really well. So we're going to connect this relay to the BMS system, so if the BMS notices that any of these cells drops to too low of a voltage, it will properly disconnect the battery protect. So that means that the battery protect could be on any setting that you want, and it will actually disconnect instead with the BMS. So you don't even have to program this properly. And these are so easy to find that anybody could hook this up. So yeah, let's get a converter board and get this going. And this is the converter we're going to use. It's a 48 volt to 12 volt 30 amp converter, and so it will work really well, and we're going to mount it right here. And because we're going to use a relay system, we can take this ground and connect it directly to the battery. Now we have the negative wire, and now we just need to connect the positive to the main positive of the battery. And now our converter has a positive and a negative line, and if I plug in this BMS, we will have 12 volts positive and negative coming out of these wires. But first we need to charge up the capacitors, so do that real quick and then plug in the BMS. Now I'm going to plug in the solar panel so that the batteries can get back to charging. Now let's check to see if we actually have 12 volts at the converter. We have 12.18 volts. That's perfect. So all we have to do is connect these terminal wires to the relay and then these two wires to the relay, and we're done. But knowing which wires to connect is a little difficult, and if you haven't used these before, it might be intimidating. But it's super simple. Let's do it. So first take your relay and plug it into the little harness. You can buy these for like $4 at an automotive parts store and make the whole process way easier. And look at the relay schematic, and you will figure out that you will have a positive that's white and a negative that's black. And so we need to connect these to our converter. And when you touch the wires of the relay, you can hear it switching on and off. And because this relay is closed across these two wires, when it's on, we can connect it directly to these terminals on the battery protect. Now that this is connected, we just need to connect these wires to this. Now we have two small wires to put into this plug. No way! So right now the relay is on, so it switched our battery protect on. And so if we have a low voltage disconnect situation, it will turn off the converter, turn the relay off, and then this will turn off. So everything works perfectly now. Isn't that freaking cool, you guys? I love that. That's so easy. And let's mount this on the piece of wood so it looks nicer. It's crazy how messy these wires get, but it's very simple, guys. This is a very simple circuit and anybody can do this. Battery protect is at option 8, but we don't necessarily need that anymore. Now we can put it to 1 or 2 or any of them. You could actually do a lower number and allow the BMS to manage the low voltage protection. If you want to use the full capacity of this battery, instead of using the option 8 with battery protect, if you have this relay system, you can instead use 9.5 or 19 volts, option number 2. For the battery protect. So program it to option number 2 if you have the relay system, then you can use more of the battery's capacity. 2 and A. Now I just need to let it go and let it save, and we're set. Now plug this back in and we're good. Now it's on option 2. So I just realized a new problem. This is a common port BMS. That means that the loads and the charger are connected through one wire. That means that when this disconnects, it will disconnect our loads, but it will also disconnect our charger, and that could damage this. So a better way to wire it is to get a separate port BMS, and I'll have a link available on my website in a schematic, and it's very easy to wire up. And all you'd have to do is take this wire and attach it to the charger wire on your BMS. It just sticks out right here. It's super simple. And so that way, if your battery is depleted, it will disconnect only the loads through the P minus, but it will keep the solar charge controller connected to the BMS, so it always has power. It's a big bummer because the common port BMSs are very easy to find. You can find them on Amazon and eBay, and they will ship straight to your door in a couple days. But the separate port ones are harder to find, but I will have a link on my website and a new schematic. And a lot of people like using these converters, but if you do not need a converter because you're not powering 12-volt appliances, you can skip this. Instead of a 12-volt relay, you can get a 24-volt relay. And I'm going to have a schematic on my website for that. I also added a schematic on my website for which terminals do what. So there's little numbers on the bottom of this relay, and you can follow the schematic and wire it up very easily. And now we're going to do a final test to figure out how much power we can extract from these batteries. A battery capacity test is a very good test to see how all the components work together and how well the cells are matched. So we have a Hall effect sensor and a battery capacity monitor. And we're going to figure out how many watt hours we can extract from this 1000 watt hour battery. And now we're going to put a load on this inverter and see how many kilowatt hours we can produce. We're going to turn it on. You can see that we're pulling 874 watts, and you can see the watt hour counter. And so right now we have 746 watts over here and 835 watts over here, so we can calculate the inverter efficiency. Oh my god! We just hit a kilowatt hour! Woo! And even though we're pulling 800 watts, every single wire on this system is cool to the touch. There is nothing that is heating up at all. So cell number 2 is the lowest voltage cell, and we're at 2.7 volts. When this cell hits 2.5 volts, the BMS will sense it, and then it will turn off the converter, the relay, and then the battery protect, and then the inverter. Oh, no way, guys, it worked! It actually worked. That is so cool. All right, so the final numbers are 1,135 watt hours. So 44.7 amp hours from a 40 amp 24 volt pack. That's really good. That means that these cells are matched and they are healthy and new. That's so good. Now we're gonna add the solar panel wire so that this battery can charge back up again. Now we are back to charging and we have 172 watts going into these batteries. I am just so proud of my viewers for watching this video all the way to this time. Like, if you made it to this far, you are amazing. Thank you so much. Also, check out the website and tell me if there's anything missing that you guys want more information on. So yeah, thank you so much for watching this video. It was a long one, but I'm glad we got to build this. This was really fun, and this thing's so powerful, and I loved building it. So yeah, thanks for watching, and I'll talk to you guys later. Bye.